In this lesson, we're going to look at how to multiply vectors together. So in the previous lesson, we looked at adding and subtracting vectors, and now we want to look at how do we multiply vectors together. So the difference is how we treat the direction of the vectors. We have two ways to multiply. We have the dot product and the cross product. So in this lesson, we're going to look at the dot product, and then in the next lesson, we'll look at the cross product. And they are both useful in their own way. So the dot product is the symbol that we use is a dot. So this is indicating that this is the dot product. If we're using the cross product, we use an X. So that will distinguish between the two, which is a little different when we look at multiplication. Sometimes instead of an X, we use a dot because sometimes the variables that we're using are X's, so we don't want to confuse multiplication with the variable. But in this case, we use the dot for the dot product and the cross for the cross product. So the dot product means take the part of vector A that is parallel to B and multiply it together. And so we will see that this is going to be a scalar product. It's not going to have a direction. We're going to take part of A, multiply it along B, and get a numerical value. So what does that mean? So A dot B is equal to the magnitude of A, or the length of A, times the length of B, or the magnitude of B, and multiplied by cosine of the angle between. So let's say we had vector A was in the direction of 53 degrees and it had a magnitude of 5, and its components were 3, 4. Its x and y components were 3, 4. So let's draw a grid here. I'll just draw a y-axis and an x-axis, and we'll draw vector A. We're going to go right 3, up 4, and it would look like this. So this is vector A. And then we want to multiply it by vector B, which has a magnitude of 7, a direction of 0, which means it's directly along the x-axis. So 1, 2, 3, 4, 5, 6, 7, and go to here. And this is vector B. So we want to multiply these two vectors together. The angle between them is 53 degrees. So the dot product means take the part of A that is parallel to B and multiply it. So if you think of vector A, I'll just draw it over here. Here's vector A. Vector A has a vertical component and it has a horizontal component. So we want to take this horizontal component and place it along B and then multiply those two together. So if we make a triangle, remember in previous lessons we looked at finding the x and y component. So to find the x component, or that would be the component that's parallel to B, would be the x component. It is adjacent to A, so to find the x component, we would have taken the magnitude of A and multiplied it by cosine of the angle. And you'll see that here, if I rearrange this formula here. So magnitude of A times cosine of theta times magnitude of B is what we're doing here. So this part is the parallel part to vector B. So the part of vector A that is parallel to B would be the x component. So we would take that component, lay it along B, and then multiply those two values together. And that gives us a scalar product because we will just have a numerical value. We will not have a direction. So if I want to do A dot B, I'm going to take the magnitude of A times the magnitude of B, cosine of the angle between them. So the magnitude of A is given as 5, the magnitude of B is given as 7, and the angle between them is 53. So the 5 cosine 53 is the component of A that is parallel to B, multiplied by the magnitude of B, and that works out to be 21. Lesson, right? You can see that they're the same vectors, so we should get the same answer, 21. If we did it as the magnitudes times cosine of the angle. We can also look at the dot product when the vectors are in algebraic form. So the way we do that, if we do let's do A and B here, not U and V. Okay, so A dot B is going to equal the x component of A times the x component of B plus the y component of A times the y component of B plus the z component of A times the z component of B. That's another way to find the value of the dot product. So x component of A times x component of B plus y component of A times y component of B plus z component of A times z component of B. So this gives us negative 21 plus 40 plus negative 2 gives us a value of 17. And we can double check that. These two vectors down at the bottom here, A and B, are the ones that we did in this previous. So if I were finding A dot B, it would be 3 times 7 plus 4 times 0 is also 21. So we can see that we got the same answer between them, or if we multiplied the components separately and added them together. So both forms work, and they will both give us the same results. So in this example, we are given the vectors in magnitude form and the angle between them. So if we were doing u dot v, so u dot v would be the magnitude of u times the magnitude of v cosine of the angle between them. So it's going to be 6 times 5 cosine of 60, and that works out to be 15. So we just want to use the form that is valid in the way the information is presented. If we're given magnitude and angle between them, we're going to use the magnitudes multiplied together times the cosine of the angle. If we're given it in component form, as here in example 2, we're going to use the other method. So A dot B will use 3 times negative 4 plus 5 times 1. So we want to look at which method works for the situation that we have. 3 4s are negative 12 plus 5 1s are 5 is negative 7. And if we were looking at scalar, we would make sure that was the absolute value, which is 7, because we want the length. So probably actually should have put that in there. Okay, but question 2 asks for the angle between them. So it's given in component form, it wants the angle. So remember that A dot B, let's move this up a bit. So remember that A dot B is equal to the magnitude of A times the magnitude of B times cosine of the angle between them. So this time we want the angle. So I've just found A dot B. It worked out to be negative 7. So I'm going to put that in here. Let's just do, we'll do the actual value. Rather than the magnitude, we don't want the length, we just want the actual value. So we'll use negative 7. Okay, so we can put that in there. We want to find the magnitude of A. Well, that's easy to find. We just take the Pythagorean theorem with the components, and we'll be able to figure out the magnitude of A. So that works out to be 25 plus 9 is root 34. And we can find the magnitude of B, again, because we have its components. So negative 4 squared plus 1 squared is root 17. So we can put these in here. So root 34 and root 17, and we want the angle between them. So if we want to isolate for cosine theta, we'll do negative 7 divided by root 34 and root 17, and then we'll do the inverse. Once we do that calculation, we'll do the inverse of cosine, and it works out to be 107. Just be careful by using, previously I looked at the magnitude, which is 7, but I want to use a -7 because I want to make sure my angle is in the correct location. If you think of the two vectors that we're multiplying, 3 5's over here somewhere, and -4 1's over here somewhere. So when I multiply them, I want to make sure that I have the correct angle that's in the right quadrant. If I use +7, I'm going to get a resultant that's going to be in quadrant 1. So I want to make sure it's in the correct quadrant. Some properties of the dot product. Commutative property just means that it doesn't matter the order that you multiply them in. So order does not matter. Doesn't matter if we do u dot v or v dot u, we're going to get the same. We're going to get the same result. The second property, u dot u, what does that equal? Well, u dot u is the same vector. So u is the same vector. So if I'm multiplying u dot u, multiplying it by itself, the angle between them would be 0. So that equals 0 degrees. So if I'm doing u dot u, be the magnitude of u times the magnitude of u and cosine of the angle between them, which would be 0 degrees. If you remember from your trig ratios, cosine of 0 has a value of 1. So if I do u dot u, the value is going to be the magnitude of u squared. And then the third property, this one's quite important because we'll use it later. What if they are perpendicular vectors? So if they are perpendicular, then the angle between them is 90. So u dot v equals magnitude of u times magnitude of v cosine of 90. Well, if you again think of your trig ratios, cosine of 90 has a value of 0. So u times v times 0 is going to be 0. So if two vectors are perpendicular to each other, their dot product is 0, and vice versa. If I see the dot product is 0, I know that they are perpendicular. And that's going to be a useful property to look at when we look at further questions.